Alright, so I'm here because I'm going to do my text corrections. For the momentum test, I got number 5 wrong. It says Mr. Dixon sneezes very loudly. One day his sneeze was so great, Tang Dan went deaf for a total of 30 seconds. The total amount of air sneezed can act as one object and was a total mass of 5,000 times lighter than Mr. Dixon, which experienced the great impulse, the air sneeze outward or the Mr. Dixon. So we know that the momentum is going to be conserved, and right away we can, with that being said, we know that D is going to be the answer. And we also know that impulse equals the change in momentum, which is m1 v1 equals m2 v2. And we know that Mr. Dixon sneezed, meaning that the air and the Mr. Dixon had the same momentum, because every reaction has an equal and opposite reaction, meaning that they have the same impulse. Now moving on to the second problem, I got number 1 wrong. It says, on the open ended, it says a red cart with a mass of 15 kilograms moves to the right at 5 meters per second. A blue cart with a mass of 7 kilograms moves to the left at 2.5 meters per second. After the collision, the blue car moves to the right at 5.17 meters per second. And for the first part, we're trying to find what is the velocity of the red car after the collision. So we had the red car with a mass of 15 kilograms and the blue car with 7. Blue, red. The red car moving with a velocity of 5 meters per second to the right. The blue car moving with a velocity of 2.5 meters per second to the left. We're trying to find the final velocity of the red car after the collision, but we know the final velocity after the collision of the blue car, which is 5.75. We're going to use this equation, m1 v1 plus m2 v2 initial, this is all initial, equals the mass of the first car times the velocity of the first car, the final, and the same for the other one. So we know the mass for the first car is 15. The initial velocity was 5, plus the initial mass of the blue car, 7, and the initial velocity. It says 2.5 in the problem, but in relation to the red car, we can say it's negative 2.5 because it's moving to the opposite direction. So we're going to put it as negative 2.5 equals 15. Final, we're trying to find this, plus 7 times 5.17. Alright, so this is 75 minus 17.5 equals 50 and 1F plus 36.19. And when we're trying to solve for this, so we're going to subtract 36.19 to both sides. So we can come up with 75 minus 17.5 minus 36.19 equals 15 and 1F. Oh, velocity, it's velocity. Final velocity. So to leave the final velocity by itself, we just divide by 15 both sides. 15 both sides. Alright, so we do the calculations. The final velocity, it's 1.42 meters per second to the left. Alright, for the second part now of the problem, it says, explain, do not calculate how to determine if the collision is elastic. Alright, so we determine if the collision was elastic. We had two types of collisions. One being elastic, the other one is inelastic. The elastic one is when the kinetic energy is conserved, meaning that the kinetic energy, when it hits, is transferred as kinetic energy. Inelastic, it means that it's when kinetic energy is conserved, it's converted from one kind of energy to another. That's inelastic. All right. So now, for moving on to the third part, which is C part, it says, now show a series of calculations to determine if the collision is elastic. So we have the formula for the elastic, which is M1 V1 plus M2 V2 equals M1 final M2 final plus we have that. So according, if it's elastic, they should equal the same amount in both sides. So 15 times 5 times equals 15. And now that we know the final velocity, which is 1.42 plus 7, 5.13. We do all the calculations, and that's coming to 37.5 equals 57.4, meaning that it's not elastic because they're not the same. The kinetic energy from the beginning doesn't equal the kinetic energy from the end. So we know that it's inelastic.